Welcome to the November 2020 session of the DevOps for Defense meetup. Today we're going to talk about digital transformation. So welcome to the digital transformation. I'm JD Black. I organize our meetup here. Welcome to everyone who's in our virtual session. We do have some new names and faces. It's always great to see some new folks coming around. If you want to see more about what we're doing, I'll just point out on the screen, everything that we do is completely volunteer-based. It is completely open to the public, and it is completely open source. And we have a website. We have our meetup information. We do try to communicate through Meetup. So I'll use meetup.com to send messages out with things like Zoom invites and all that, as well as post entries into our online blog with all of that information each month. And then I keep a short synopsis of what we do and publish that out with links to all relevant material. So I hope you find that useful and get a little bit of value out of that to help us improve our work lives on a daily basis. We always start with our code of conduct. Just strong reminder, this is an unclassified context, so please no dirty words. Do treat everyone with respect and professionalism. Do not talk about your private, sensitive, or proprietary work. Your secret sauce is yours, so please keep that to yourself. But where you can, please do feel free to talk about your experiences, what you need, how you are looking to improve, and see if anyone in our community can share some ideas or provide some help. We really want to focus on learning, so do try to share your thoughts with others to help them learn, and do reach out and try to learn from them. And in a virtual setting, we do ask, if you're not speaking, do mute yourself. But I also want to really encourage this to be a dialogue and a collaboration. Since we don't have that face-to-face interaction that we would normally have, I think just the digital interaction and creating a conversation is much more interesting than doing a presentation. We do record these sessions for those who are new, so just be aware of that. I've taken your pictures off the screen, but if you communicate, if you come off of mute and you interject yourself, just be aware that we're being recorded, and we do publish that session recording to YouTube every month to give anyone who couldn't participate access to what we're doing and what we discuss, and hopefully there's something useful there that we can take forward and apply to our daily work. A quick highlight. I'm sorry. My dog went nuts when the doorbell rang. So we did see the DevOps Enterprise Summit happen a couple weeks ago. This was a virtual session, so it was very different than past years, but it still had a lot of really great content. So what is a virtual conference? Think of it like a custom-built YouTube is really how it was put together. It was very cinematic in nature, and that was very clearly on purpose. But what I've done is highlighted a few talks that I came across as I participated and went through the content that really spoke to me and talked about, that gave me some ideas about how to improve work in our industry. One that I do want to specifically highlight, the Air Force and the Deputy CIO of the Air Force in particular did a great presentation with the Chief of Platforms from Kessel Run, talking about their journey and what they've been able to accomplish in our defense domain, which was really interesting. One nugget from that talk that I'll share with you is why did they call it Kessel Run? The story they tell is it's called Kessel Run because they knew they wanted to work in a different way. They knew they were going into an incredible bureaucracy, and they knew they had to smuggle in these new thoughts and new ideas if they were going to be able to utilize them. And so I thought that was really interesting. They also talked about how when they walked into work, it's like you leave your phone at the door and then you walk through a time machine. And I've had that experience in a number of instances in my career as well. It was really interesting to hear how they dealt with it and some of the steps and measures that they've been able to take and the initiatives that they have going forward. And I think in our industry, they're really, the Air Force in particular, does seem to be in a real leadership role. So in a few months, if you weren't registered for the conference, talking with Gene and his folks, this content will be made available on the public YouTube. I would encourage you to keep an eye out for them as they come through. A lot of great talks, a great talk from GitHub, a really, really interesting and insightful talk on inclusive organizations, and then a number of other talks that I thought were really helpful to sort of set our thought process as we work through our own improvements within our team. There's usually a theme to these conferences, and I would say this year there wasn't a really solid, organized theme. What I saw come out over and over again was a crystal clear focus on outcomes, and then making sure that everybody's aligned and understands why these outcomes are important and how you're going to measure your success. The Walmart talk that's up here really kind of drove that home, and think, this is one of the largest companies in the world, largest retailers in the world, how they're transforming themselves and maintaining relevance when so many others in that market have really just fallen off the face of the earth. It was really interesting, very exciting, and I thought it was quite valuable. So hopefully this content will be made available, and I would encourage you to check it out when it shows up. So let's dive right in. What is digital transformation? Well, let me Google that for you. Google just points you to this first definition, which I find it interesting. I won't read it to you, but all
right now,
it does talk about how this is fundamentally changing. Uh-oh. How we're fundamentally changing how we operate and deliver value. And that's really difficult in a world, especially a world of the defense industry, where bureaucracy tends to be king. So when you start making changes, you start challenging that bureaucracy. I think that's an interesting obstacle that we all face. And what I find really interesting is oftentimes you find really powerful and valuable partnerships within our domain, where you can team with members of government, of FFRDCs, as well as industry, and really create some incredible outcomes. But there does have to be a willingness to work together and drive that fundamental change. So I did actually like that definition. Perhaps a more credible, quote unquote, given the source from MIT, is the digital transformation marks a radical rethink of how we use technology, people, and processes to change performance. And here he's talking about business performance. I think in our domain, it's really about mission performance. How are we delivering mission value to our warfighters? And so that I like that definition as well. I do think with all the research and reading experience that I've seen in various contexts on the topic, I do think that in some places the words kind of paper thin. What is digital transformation? It's that it's the new favorite buzzword that some executive has latched onto, or it's some phrase that someone's put in place to sell their next widget or whatever. I think it's not unlike DevOps in that way, where there is a little bit of a marketing spiel and buzzwordism around it, and our challenge is to really get our heads around what's the underlying meaning. And what I'll ask each of you to do is, as I go through some of my thoughts on that and share with you some of the research that I found, please feel free to add, adjust, or contradict based on your experience in our domain. And hopefully we'll have a good discussion on how to really tune this in ways that is valuable for all of us. So let me start with my personal assertion. I really see, DevOps, DevSecOps, DevStar. I see it as the digital factory of the digital transformation. And so what do I mean by that? I think the two are intricately intertwined, and that's why I wanted to talk about digital transformation here. And I almost have convinced myself that it doesn't matter, what kind of product you produce, the principles still apply. If you're in a context where you think they don't apply, I'd love to hear more about that. But what I tend to see is an idea that this is a software thing. You're a bunch of software people. You just don't understand my domain. But in reality, and we'll talk about a couple examples of this, what I really see is engineering moving away from, we moved away from slide rules, before I went to college. Now we're moving into a whole new paradigm. We had kind of isolated stovepipe discipline oriented tools. I really see those things coming together in new ways, and I see teams integrating processes and integrating technology in completely new ways to change how systems are created and delivered. And so that's kind of my thought process and the basis for the assertion. One element, if you haven't read it yet, I do want to recommend it. It's like 18, 19 pages, and it's quite good. Dr. Will Roper, the Assistant Secretary for the Air Force for Acquisition, Technology, and Logistics, recently published a paper titled "Take the Red Pill, the New Digital Acquisition Reality." If you're a fan of the Matrix, this paper is right up your alley. A lot of analogies put forward, a lot of really interesting propositions that tie into some of the ideas and structure of that Matrix story. There were kind of a trinity that was put forward of ideas, and you have to recognize this was really focused on acquisition. But it's interesting because it sets up a dynamic. It creates an expectation. What is the responsibility and role of the government in acquisition? What is the responsibility and role of industry in acquisition? And how do you create and deliver value for who is effectively, the real customer, that end user, that warfighter who has a mission to achieve? So the three principles he laid out, the Trinity. Number one, and I think this is going to be really interesting. I see indications of it happening in our world, is that the government will own, share, and furnish the tech stack. And I think to some people, that's a very threatening idea. Some just flat out terrifying. But when you look at the commercial world, think how many years it's been since getting to the cloud and becoming cloud native and then becoming cloud first has been, it's almost the no-brainer first step. What I see happening is with programs like Platform One, as an instance, I see more and more of that. I see it's how do we set ourselves up to work in that commoditized tech stack environment. I do think you'll still need to tailor that tech stack to the needs of your processes and your requirements and your product. But I do see a lot of advantage as long as availability is understood and maintained. And in terms of making these moves, transitioning our processes and our tooling and our teams to actually work out of provided tech stacks, particularly tech stacks that are now available, in secure cloud environments.
What do you think happens with IRAD or other corporate intellectual property that's developed locally in our current working environment? How does that map to a government-owned tech stack?
Well, I think you're kind of getting to what is tech stack, what is the definition of tech stack? And I really think that from what I read, what I've observed in my experience working different programs, is think of it as your infrastructure.
Mm-hmm.
You know, do you need to own your GitLab license? Maybe you do. Maybe you have a really good reason to own that. But maybe it's better for the for GitLab to be owned and hosted by the government, and to make that available to programs, and just simply grant you users. Very much like the commercial world. Now, I don't think that has, when you're talking about pure infrastructure, I think there's this interesting challenge, right? All too often, industry gets all worked up about how, the Me Too mentality. I can build a cloud just like Amazon. Well, that's stinking great. I love it for you, but you can't own it, operate it, and maintain it at a price point anywhere close to Amazon. So you're already uncompetitive in a commodity space. You shouldn't do that, right? You should really look for, best value to that, whether it's to the acquisition agency or to the end user, the warfighter, and focus on building them capability rather than reinventing, commodity infrastructure.
Agreed on all fronts, JD. I can't get a SIPR token if I'm an IRAD participant. If I'm on a contract, no problem. It's
Right.
the access that I'm concerned about.
A valid point. I don't really have a experience or much knowledge in that domain, but it's, when there's an expectation for industry-driven innovation, industry-funded innovation, the obstacle you're talking about is definitely something that's going to have to be overcome, without a doubt.
And this is great. I kind of wanted to ask similar questions. When I first read it, Take the Red Pill, I read own your own tech stack. I thought that meant me own my own tech stack, but you're saying share it with what the government has already created. Is that what you mean?
Yeah. When you go through it, I mean, I literally cut and paste these straight out of the document, right in the conclusion. And what I take away from it is industry. Here's a simple example. Program A builds out a beautiful tech stack. We've got our Linux, and we've been able to secure that. We can stig it. We can do all the stuff, get it certified, and it only cost us, $15 million to build it and $7 million a year to maintain it. And Program B, you go over to Program B, and they have done the exact same thing. And they managed to do it for 3% less. What a huge win for the taxpayer. Stop doing that. Just stop it. Find a way to provide commodity access to teams such that they can take advantage of that without having to recreate a wheel, with less efficiency and at greater cost and less stability than commodity providers can give you at the click of a button. That's really the way I interpreted that statement. Now, the paper, I think, goes a little bit further in terms of owning elements of the factory. And I think there's a little bit of challenge and tailoring that has to happen there. Some things that makes perfect sense, right? If, I don't need to build and configure and stig and maintain a Nexus repository, for example. I just need the URL and the credentials to use it. I'm sitting here for this meetup. I didn't build my own instance of GitHub so that I can publish my material open source. I use a highly resilient, freely available instance online that I can log into with the necessary credentials and control my own baseline through that. But it would have cost me an arm and a leg to create that if I had to replicate it. And when the government's working so many different programs and replicating the same thing over and over again, I see it as a fundamental economic value question. Why is that valuable for the government? And how can they streamline it?
That's where like you could bring in that concept of like Wardley mapping, right?
Mm-hmm.
And if you look at owning that tech stack and all that sort of stuff, that is all moving towards commodity. So like you said, you shouldn't build that, and instead, the business value is focused on doing the useful things with those simple building blocks and creating the higher order functions and capability based off of those.
Yeah. Create the photon torpedo, right? That's magic. It's the new thing. But don't recreate the email server. That's
right.
Solved. Number two, I found interesting in the way he constructed it, warp from the tech stack to the edge effortlessly. And I'll give you my interpretation. It was put in the context of, how do you get from lab to, fighter jet in an Air Force context. So the fighter jet is kind of the edge. Not all systems are fighter jets. And I really took this as, how do I get from good idea or from development into mission utility? It's kind of the way I framed that number two in my mind. And this is, again, started to reinforce the principles of DevOps, understanding how to streamline lead time, how to ensure confidence in your deliveries. I really see a lot of direct parallels to what we've, been talking about in the DevOps community with what is laid out in this paper. I do think there are interesting cases where the edge is a fighter aircraft or a ship or a, whatever it might be. But I think that delivery path is simply an element of tailoring your continuous delivery process to the right environment and context. Some contexts will have a lot more challenges than others. But fundamentally, I simply see it as flow. How do you get value out to the warfighter who needs to use it to achieve their mission? And then number three, he laid out was create before you aviate. And so again, very much in Air Force context, he talked a really interesting story about a couple of aircraft, a training aircraft, where they basically modeled the whole thing, ran a whole lot of digital simulation and testing before anything was created. And there's a lot of talk about how to do that and drive an acquisition strategy and context in there. But I think my whole takeaway was this is really the tie to what does digital transformation mean in our world. If you can quote create, number one, what does that look like? How does it encompass the various disciplines involved? And how does it integrate into a meaningful product representation? So, well, I've got a few things that really talk about at least my view, and I look for your context on what that means and how we could apply it into our domain. And then the last thing is worth mentioning. He states, rather than building better systems, build systems better. Look for those elements of faster design, seamless assembly, and easier upgrades. It kind of gets to that, speed to need challenge. Recognize that the system you build today isn't going to meet the needs of tomorrow. So your real value proposition is, how do I respond as quickly as possible to the needs of tomorrow and build a system, build my factory to optimize that the delivery of that value. So let's drill into eCreate a little bit. What could that possibly mean? Here's a couple of thoughts that I had. I'll start with my favorite. I'm a bit of a Formula One fan. I hope maybe there's a couple of race fans out there with me. But, whenever I think of, digital engineering and eCreate, one thing that comes to mind immediately for me is the way these, ridiculously high performance race cars are built. They digitally model every aspect of it, and then they digitally evaluate and analyze that using things like computational fluid dynamics. They understand the thermal characteristics, the mechanical loads, the aerodynamic loads on that car before they ever go off and shape a piece of carbon fiber. And it's such a powerful technique, a powerful tool, that it's actually regulated. In the upcoming new regulations for Formula One, in fact, if you win the championship, the next year you have more constraints. You are at the bottom of the totem pole in terms of the number of hours of computational fluid dynamics processing you can do to try to level the playing field and limit cost. So it's an incredibly powerful tool, gives you incredible insight, and I think it's a great example of digital engineering and digital transformation. And I think the principles are directly applicable into what we do. Another element is I thought was interesting was electrical engineering. We build some pretty exquisite electronics. Those are all, modeled and developed in digital engineering tools. I have seen cases where you create your digital, PCB design, and then you translate that into a drawing, and then you ship that drawing off for fabrication. And then the fabricator comes back and says, hey, can I get the Gerber file that created that drawing's based on? You ship them that. The Gerber file controls the manufacturing process. You get a product back, and then you're wondering, does it match the drawing? You got to wonder, maybe the Gerber file is the real baseline there. Maybe if it's the basis of your production, it's the critical element. Not that drawings aren't useful and important, but maybe the drawing's a report. Maybe. And so when you think about, again, thinking about commodity stuff, for electrical devices, at least maybe we have some specialized things where requirements push us out of the commodity space. But if I design a new PCB and I want a copy of it, I upload my Gerber file to some factory in China. I give them $8, and 10 days later, I've got a few copies of a custom PCB that I've developed and designed. It's been commoditized to an incredible degree, and the critical question here is, how do you control and evolve that? And I think there's a lot of power in the digital tooling around that. Another one that came to mind was RF communications and radar. A ton of modeling and tooling, understanding the side lobes of your array or your sensors, antenna pattern, tons of performance and sensitivity analysis that you can do. Almost have a full digital construction of that RF and its performance within a digital environment. The question is, how do I capture that? The question across the board here is, how do I capture it? How do I control it? How do I configuration manage it? How do I integrate it? How do I analyze it and get objective evidence out that gives me the confidence to move on to the creation of the tangible physical artifact? And then, realize the real world is, a bit of a fickle mistress sometimes. How do you make sure that the physical artifact actually demonstrates the performance characteristics of your digital environment? So I'm curious to get a little bit of feedback. I really see our industry becoming more digital all the time, and where I see our challenges are, there's tools to do all this stuff already. They're on the market. You can buy them. I think our challenge tends to be integrating things in such a way that makes them useful and valuable within a domain. And then the second piece of that is ensuring that the tools have the fidelity that you need to have confidence in the product that you deliver from that digital environment. What do you guys think? Does that premise make sense?
I always agree with the or the premise of the modeling from the hardware side of things, where you can kind of deduce things down more so to like the basic fundamentals or physics of how things are going to interact. I still always struggle with the trying to apply some of those same concepts into the software realm, right? And I I don't see the same capabilities out there from a tooling perspective to because software has to a certain extent almost has like a zero cost of change,
Right.
And and so it's almost oftentimes it's building the model and the running implementation can almost be one and the same in terms of your total effort.
Yeah, maybe let me phrase it slightly differently and see if I catch your drift. What's the real value in digitally modeling a digital thing? If you're spending the same energy to model the thing as to build the thing, are you getting any value out of it?
Right.
Yeah, I absolutely agree with that. Another interesting idea is this concept of a digital twin. So what is a digital twin? It's really that digital replica. So imagine that we have created we've gone through our digital engineering processes. I have this incredible, exquisite, configuration managed digital engineering suite of artifacts. I have created that in the real world. Does that digital instantiation still have value? And I think digital twin tells us that it does. It's that digital replica of an actual thing or process, etc. That's something in the real world, and it gives you a representation with connectivity into that digital thing, into that physical thing, that allows you to understand how the elements, what are the elements, the dynamics of it, and how it operates across its life cycle. How do you connect it, your digital instantiation, to the real world item? In a DevOps context, we would think of that as elements of feedback. How do I measure what's going on in the real world and pull that information back to help characterize that thing? And then how do you use real-time data, or how do you collect that real-time data using sensors to allow you to do really interesting evaluation, right? Maybe it's lifetime extension engineering support, or reliability analysis. I think it's got some really interesting applicability in our domain. I also think it may be overkill in some cases. When we think about true, pure commodity, COTS servers in a rack, do I want to build a digital twin for that? I'll probably spend more building the digital twin than I paid for the rack and all of its contents. So maybe there's not value there. Maybe it's just disposable. But maybe, depending on your context or depending on the uniqueness of that configuration or the mission criticality or availability requirements, maybe having that digital twin to give you the understanding, analytics, history of it makes a lot of sense. And I took another quote out of Dr. Roper's paper here. It says, "We must decide when a model becomes so realistic we accept it as a full substitute for reality." I think there's this interesting struggle that we deal with in what's good enough in terms of fidelity. Using a digital twin gives you an opportunity to collect information and make that information relevant to your baseline, perform those analytics, and validate to some extent the analytics that you use when you're producing that product. So I think it's a really neat way to accomplish that feedback loop that DevOps says that we would really be focused on in the second way.
So I'm going to step in here and read some chats from Shelly Cummings, just in case you can't see him, JD. She's one of the people here tonight. I'm a configuration management analyst, she starts, and I have a passion toward that end and want to help.
Me
and
too.
She talked about digital twin being configuration management. And what about cyber requirements that drive the digital twin? And that was her last comment.
Yeah. So I tend to think, what is DevOps? I used the term earlier, DevStar. So how do you differentiate? Is DevOps the same as DevSecOps, the same as DevStarOps? And the way I take it is fundamentally they're the same philosophy. The question is what do you need to emphasize? There's some really interesting presentations that come out of the Air Force to that end, where they talk about the myriad of things that may exist in the middle, whether it's DevSecOps, DevSafeOps, DevNukeSurityOps. There's all these things, and the question is, how do you incorporate the given thing into your practices and your processes, and train your teams on it to be effective in achieving the objectives associated with the thing. So how does it apply to digital twin? The digital twin has some interesting real world characteristics that are continuously being monitored, updated, and analyzed. And depending on what the actual artifact being represented by the digital twin is, the security requirements for the associated data may be quite extreme. So employing the right practices, meeting the requirements associated with those, having the full engineering traceability, basically stop treating security requirements as special. They're requirements. Put them in your requirements baseline, build a test for it, create objective evidence that shows you meet them, repeat the test when you change the baseline. A lot of the core principles that we want to push forward with a DevOps mentality, I think, apply equally there as well. Because the digital twin probably sits in the lab or in the engineering environment, I think there may be a bit of a idea that you can apply less rigor to it. I think that's dangerous. I think you really need to treat it like a true product. Deliver its components and content as a true product and secure it as operational data, just like you would any other operational data. I hope I answered your questions.
Yeah, go ahead. I'll pause for a sec. So then, yeah, I think that was pretty good. But Shelly, feel free to chime in. Sean, I was gonna bring something up. It's kind of interesting. I work on like a strictly software-based project, and we have an interesting thing that occurs when you work on object-oriented codes for long periods of time. I don't think it's any particular idea the people who invented object-oriented software design saw in the beginning, but it definitely falls out over a long period of time where bloat occurs, and you have developers that work for a particular time frame on a particular section of the code, and they do things a lot differently. And what ends up happening is you get tight transitive coupling. And there's a lot of classes and methods that fit in one particular section that need to be broken up. And one thing we did is I use PTC currently right now as an MBSE tool, and it is so tight to this this broader digital fabric that's coupled with even the digital thread and everything else that we're discussing right now. But we reverse engineer the code, and it's kind of like a layperson's reverse engineering. It doesn't do the real levels of abstraction sometimes or the real heavy levels of abstraction don't always come through. But at least it gave us an idea of where the layers of complexity sat within the code. So it does sit kind of like a digital twin. And there is ways in which PTC can be built out to literally sit, and the quote that's on the bottom of your screen right now, there is ways in PTC to build compilable code. I don't think they're as nice as they play them out to be, but it definitely can do it. But there's not always zero cost, and we're always looking for ways, I guess, right now, to take this older code and reuse portions of it and repurpose portions of it. So that there's a heavy cost actually associated with us and the software side, because you can't rebuild everything with 30+ year code or 20+ year code or 10+ year code that suffers from this bloat is hard to pull apart. But at least you can get an idea of what the work is. And I think that's something that's extremely powerful as far as creating that digital thread and then coupling it to other stories and mapping how, a lot of people will give you a number. They'll say, well, I refactored this code and I reduced it by 10,000 lines, right? But if you kept all the classes in the same directory, or all, that doesn't necessarily mean you reduced tight transitive coupling. You just made the code cleaner, and it still has some nasty effects working in local regions. But anyways, it's just a little different perspective on some of that. So.
Oh, I appreciate that. That's good. Yeah, so I certainly agree. Tools like that can help with an understanding of how things have built and evolved, right? And so yeah, with certainly with legacy or existing baselines, right? You can have, using tools like that to kind of help understand what's there and ways that you can tease things out. I certainly see value in that. Just when you think about the complexity that's inherent in, that's inherent in software when you're trying to essentially have, you have a whole series of simple rules to try to create, a more complex existing system. I still have yet to see a software tool that provides, or even a modeling tool that provides that level of detail that you would need to be able to, fully design and model software up front to then be able to run in the chaotic type of environment that actually sits in a real running environment where you have to deal with the complexity or the failure of any of the the physical hardware underneath or the other components that it's interacting with at any given point in time.
Oh, no, I totally agree with that. Yeah, that's not there yet for sure. It gives a hint and helps with our development process, but it does not.
Yeah.
There's nothing like this yet. Yeah.
Yep. So, but I definitely like the digital twin especially from like the hardware side of things, or the things where it's, it's more expensive to create, or there's potentially a longer lead time on some of that stuff. Certainly, there's always a cost or lead time with, software changes and stuff like that. But I think you can overcome a lot of that by building and following, the practices of trying to decompose and simplify as much as possible. And
yeah, hey, somebody's mic's on. Somebody's mic's on. Just to put it out there, somebody wants to do it. But yeah, Sean, I totally agree with you. So maybe you could say that I kind of have like an ugly digital twin. That's helpful for me. But it doesn't do the exact thing. It's kind of like, truthfully, it's kind of like a semi-digital twin. It's helpful, but it's not truly there.
Right.
But it would be amazing if you had got there. Yeah.
That's where I think it kind of gets down to fit for purpose, right? And I think a lot of times on like the things that JD was showing about in terms of like the way that they're doing this really complex computational fluid dynamic modeling of race cars, right? That is totally fit for purpose, because, if you're going to spend, $1 million building a car and you can run through, hundreds of thousands of iterations of it, it makes sense to spend that time and energy up front. And but from like a software side or other things, right? That same level of fidelity is likely not needed. And so I think that's where oftentimes we get stuck in our environments, is that we try to go to that exquisite perfection of fidelity in all areas at all times. And, it's probably not really fit for purpose in a lot of areas. So
it's extremely interesting. You guys bring up the CFD example, because I worked for a very long time in computational fluid dynamics, and coming to model systems from a different perspective or a different higher level was a hard transition for me. But I can see where these teams do benefit from keeping track of some of their smaller components, like particularly on those F1 cars. They have little tiny vents. Each vent has its own CFD model. It's actually extremely complicated, their entire system. I think earlier he was hinting at this. Yeah, interesting perspectives on how you need to tailor your particular solution to your problem. Nothing's perfect and nothing's unique. It always has to be tailored, it seems.
Right.
Absolutely. Yeah, it's I'll go back and build on that with there was a lot of talk at the DevOps Enterprise Summit this year about anti-patterns and, kind of, please don't step on this landmine that we stepped on. One of the anti-patterns that came up often was the idea of kind of cut and paste software factories. Just don't do it. And it's very much to the same point I think you're making, is every product's different. And the factory you use to deliver your product is going to be different. It's going to be tuned and tailored to that product. So, I really thought that was interesting because it gets to, the fit for purpose point. And it kind of gets to one of, Dr. Roper's comments, what does it mean to own that tech stack? It can't mean that we found one size that fits all and we'll just make it available. You're diving straight into an anti-pattern that is proven not to work. It's understanding which parts of that tech stack make sense. Just like how deep do I model my software in a model-based systems engineering tool versus just simply building the digital element. Where's the real value coming in, and how do you connect the dots? How do you keep the traceability? How do you maintain the configuration management? All become critical aspects to being successful. But,
JD, this is Shelly Cummings.
hey, Shelly.
Before we get too far along, you had, and we moved into more of a software conversation, but you had said something, and I'm wondering if you can just repeat it. You might not be able to repeat it exactly, but you mentioned something about something that was dangerous. And it was in regard to once, I think it was Karen who had asked the question with regard to, because I am a configuration management analyst and I want to be able to best support from a CM perspective, and where does CM fit into the DevSecOps perspective. And I will tell you that I am more versed and strong in hardware configuration management, or even like our like how we need to track virtual assets, etc. And I'm learning more and more about software configuration management, though that is not really my background. So with that said, I was wondering if you could repeat what you said with regard to something being dangerous in tracking our configuration, even in this, like, we have to adapt and overcome and be agile or whatever. I want to be sure that it seems as though there's some confusion with how we still track and maintain this digital twin in a constantly evolving environment.
Yeah. I don't remember exactly what I was referring to as being dangerous, but the good news is here in a couple of days, I'll have this edited down and published on YouTube, so we can all go back and see what was dangerous. But I want to make a little bit of a configuration management spiel, and it's great to have configuration management people with us, because I think if you do configuration management right, everything else gets so much easier. But
yes, thank you.
My common pitch is, look at what's been observed and reported from across industry. For years, the DevOps, the State of DevOps report has been informing us that the #1 leading indicator of high-performing teams is good configuration management. So if you are investing in good configuration management and ensuring that it's employed as a discipline across all your organization, you are going to struggle to perform. Now, I'll also kind of, throw it back in the anonymous, configuration manager's face a little bit. Configuration management is not something that an organization inflicts upon others. It's a discipline that good engineers apply to their work product and to how they deliver, develop, and evolve that work product. So I often like to ask, if I find myself sitting down with a configuration management lead, my first question is, do you have a configuration management plan? The answer is always yes. My second question is it rigorously configuration managed? And they kind of blow up. They just take offense to it. The idea that applying the discipline of configuration management to configuration management is heresy, right? It's we'll arrive at the singularities before too long. But I think it's absolutely, super important. I wish I remembered what was specifically I had said was dangerous, but you can always, if we go back, we'll get the video out. If you have any thoughts or additional comments or would like to talk about it more, feel free to reach out with the email, on the front matter of the charts. And I'll repeat it again here in a little bit.
Yes, sir. I'll do that. Thank you.
Okay. So this kind of gets to the question, is this just a software thing? And I'm going to make the case, hopefully, that really this is a digital engineering thing. We've talked about, the implications of digital engineering in Formula One. We see it in things like satellite communications modeling. We see it, across the board, frankly, in a lot of anytime you're building something that requires CAD, thermal analysis, mechanical analysis. Nobody builds PCBs anymore by inventing them on a drafting table. The world really has gone digital, the engineering world in particular. And so what I find interesting and curious is, that electrical engineer 3 cubes down comes over and says, oh, this is all great. But that's just a software thing. And I'm not a software nerd like you. The reality is almost everything they do in their job on a day-to-day basis is completely driven by software. And understanding that software is really just your most powerful tool as you work your way through that digital transformation, I think is the most critical piece of that. And to sort of drive that home, I mentioned the State of DevOps report. These are the key practices of high-performing teams. I went ahead and incorporated them here again. But that version control, aka configuration management, is the #1 thing that you need to be doing with your digital environment, with your digital baseline, and as a practice and discipline within your teams if you want to be successful. I think depending on your product, a lot of the specifics of how you implement these things changes, but I do think it's absolutely foundational. Of course, it all applies to software too, but I don't think it's a software thing. Okay, last chart. We've been talking a lot about kind of digital engineering and what that looks like, but I didn't want to just blow past the word transformation. And so I went out and I, watched a bunch of presentations, read some articles and publications on it. And one that really resonated was an interview, and I'm not going to botch her name, but that Mary, a vice president at Gartner, gave. The link is there. It's also on our website under the resources tab, if you go to devopsfordefense.org. But she talked about, any transition is hard. So how do you survive your transition? How do you get through that transformation, with a team or an organization, a program, what have you, intact? She sets out 3 really clear top-level ideas that I thought was, potentially enlightening. First, let me say that's one of the best 29 minutes I've spent watching her interview in the last couple of months. It was quite good. But she tells you first and foremost, set a clear North Star, know what you're transforming into, know why you're doing that, and make sure that you can communicate the reason you're doing this to your team. Everyone has to understand it. One that I'll highlight, one kind of facet of that that I totally resonated with was the idea that if it has any corporate speak in it, it is forbidden. You have failed to set your North Star. And I love the example that she gave so much that I transcribed it here on the screen for you. But we find ourselves dealing with that all too often in our world. My business development friends will show up and talk about how everything's flawless engineering execution, blah blah blah. No, it's not. Engineers struggle every day. They create incredible outcomes, but nothing in life is flawless. So how do you set goals that are reasonable, realistic, and you can communicate and avoid that fluffy, meaningless jargon that often comes with that? The second was establishing principles, guardrails, and priorities. What I really enjoyed about her view on this is that your principles and guardrails actually provide clarity on your priorities. And they give real people what they need to make a decision. So the test that she put forward that I found really exciting was if your principle can be inverted and make sense, it's probably okay, right? Because it allows people to apply it to make decisions. But if your principle is, I want to delight my customer, if you take the opposite of that, I want to enrage my customer, nobody's ever going to say that. It will never happen. So the principle you put forward doesn't help people make decisions. If you instead say, I prioritize security over speed. We want to deliver, or maybe it's the opposite. We want to deliver regardless of regulatory constraints. Okay, I clearly have prioritized speed of delivery over meeting regulatory requirements. No one should ever do that, especially in our world, but it gives people what they need to make a decision. And the last one she talked about was hack the culture. I really enjoyed it's not a hack if it's going in and completely boiling the ocean. Hacks are small things that you do and need to immediately in the now. And then I liked also how she talked about understand what your systemic obstacles are, because they cannot be hacked. The example she gave was a law office where they wanted more collaboration and creative execution among the members of the firm. Well, each one of those members charges and bills hourly to specific clients. So if you want them collaborating dynamically, how do they charge their time? It becomes an impossible task for them to do. And so you need to understand what your systemic constraints are. Maybe you need to address and tackle them, but at least make sure you comprehend them and don't expect others to behave counter to those systemic obstacles. So a great talk. It's also published in the resource section of the website. If you've got 29 minutes to go and listen to Mary give a fantastic interview, I think it's completely worth it. That
Hey, JD,
concludes,
is the website in the email, the invite? Is that where the website can be found?
you know what? I'll do you one better. It is not, but it's easy. So if I go home, DevOpsForDefense.org, it looks just like this. This is the website that we hold for the meetup. It's actually, interestingly enough, it's completely automatically generated from a GitHub repository. So everything literally on this website is open source for you to go browse if you so choose. The link to the GitHub repository is right here. The link to the YouTube channel is here. The link to Meetup is here. I'm a very antisocial person. I do have accounts, but I don't use them. I apologize. But when I say go to resources, I mean this resource tab. And so,
awesome.
Yeah, I just published the interview. It's on YouTube. It's right here at the top of the page. And then Dr. Roper's presentation, or Dr. Roper's paper. Where is it? web.
I've got a PDF of that for my guys. Oh, you got it here. Okay.
Yep, Dr. Roper's paper's here. I did find a copy online, so I'm hoping I don't get in trouble for posting that.
I had the version called "There Is No Spoon," and then three or 5 days later they changed the title to "Take the Red Pill." Kind of funny.
Cool.
And for Shelly, this is fully CM'd as well.
Oh my God, yeah. Oh, Shelly, when I say is your CM plan fully CM'd, man, we should talk about what fully CM looks like. That whole website is completely contained in this repository and this directory. It's a ton of fun. It's awesome. I love that stuff.
He's walking the walk.
Nice.
With that said, there are tons of other great resources. Here's a short sampling. You can find all of it on our website. Please, never hesitate to Google it either. But a lot of great stuff. So with that, we'll call it a meetup. Thank you all for coming and spending a Thursday evening with us.
Thanks so much for doing this again, JD. I'm feeling guilty. I might be willing to step up and actually do something.
Well, help get the word out. If you enjoyed yourself, please come back. Please bring a friend. If you think that you have something that you could contribute to our community, I'm always excited and welcoming of guest speakers and presenters. And although next year is or next month rather, is our 3-year anniversary, I unfortunately don't yet have anything special lined up. If I do get something special, I will be sure to announce that through the meetup. So if you haven't gone to meetup.com/DevOps for Defense and just registered as a member, please do that so that you can see any updates that come out. Otherwise, watch for blog posts on the website. If you're old school, there is an RSS feed that works that'll give you an update off the website as well.
Cool.
Awesome. Thanks, JD. Appreciate it.
Absolutely.
Good presentation.
Thank
Great
you
stuff.
so much.
Bye.
Take care, all.